Welcome to another PyPhysicsSandbox tutorial video. In this one we're going to look at pin joints. Now pin joints are basically like connecting a metal rod between two shapes, and so the shapes can move, but they will stay that far apart because the metal rod doesn't allow them to get any closer. So I've got a basic program here where I have a floor, and in this case I'm setting the friction on the floor fairly high so that anything that is rotating against the floor will get some traction. And I'm setting the elasticity of the floor to 0 so that there's no bounce associated with it. So anything that drops onto the floor will just stay there. So what we're going to do is we're going to create a couple of wheels. And so I'm going to create these two, and if you've noticed before, the first parameter to ball is the point of the center of the ball. The second is the radius. This third one here is an optional parameter that is the mass of the ball. So if you leave that out, then the physics engine will calculate a mass based on the area of the ball. If you put it in, then it gets that mass. So I want to make certain that these are fairly heavy. And then, of course, I'm going to set the color. In this case, I'm going to set it using RGB values. So you can pass in 3 separate RGB values, which actually is really nice. If you want random colors, then for each of these you can pass in random.randint from 0 to 255 and get a totally random color. I'm also setting the friction of the wheel to high and the elasticity, the bounciness of the wheel, to nothing. And then because these will have motors associated with it, I'm going to set draw radius line to true so that I can be guaranteed that I'll know if it's turning or not. And then I'm going to create another one of these. So I'm going to do some cut and paste here and hopefully fix everything up so I don't get cut and paste errors. I'm going to change my location of these. So I'm going to go ahead and run this. I've got draw down here so that it will draw things but not do physics. So I have these two. Now for pin joints, what we're going to do is we're going to create a car, and this is based on the PyMuck example. So we're going to put a box up here and then connect it to the wheels so that everything stays together as the wheels move. So let's start with the chassis. And again, I'm setting the mass of the box here to a particular value. And the elasticity to nothing, so it doesn't bounce. I don't have to set the friction of the box because it's never going to rub against anything. Now, I want to do a run here just to show you what happens when we have have physics enabled. It just all falls down, and it looks like a car initially, but then nothing's connected. So what we need to do is we need to create some of these pin joints. So the first parameter for pin is the point on a shape that you want to connect the metal rod to. Then we have the shape. Then we have the point on another shape. And then the other shape. So that connects those two points with a metal rod, essentially, in terms of the physics. So let's go ahead and run that. So now you can see that we have this metal rod here from the center of this wheel to that corner of the chassis. So we're going to continue, create a few more of these. So we'll create another one. So this is to the bottom corner. Now that's necessary so that the box actually stays above these when it's connected to the other wheel. That way, if we only had the one, the wheels themselves could get pushed away and then the box could fall down. Okay, and then I will do some copy and paste here. This is going to be 155 because it's the center of the second wheel. And then 125 because it's the opposite corner of the chassis. Go ahead and run that. So now we have an actual car. It rolls downhill, of course. We'd like it to roll uphill. So what we can do is we can put a motor on wheel 1. So we'll have a rear-wheel drive car here. So that pushes it up the hill. It'll eventually fall off the edge and get removed from the simulation. We can stick a motor on wheel 2 as well if we want an all-wheel drive. In this case, you can tell that the rotation of that front wheel is now in sync with the rotation of the back wheel. Without that second motor, if you pay attention to the radius line, the front wheel doesn't start rotating until it's on the floor and being pushed by the rear wheel. The overall behavior of the car is the same in this case, but depending on your simulation, you may want one behavior or the other. So that's the basic use of the pin joints. You create a connection of constant length between two shapes.